All right, so we're going to start out with the insertion sort implementation that we went through in the insertion sort video. So that's exactly what I have here. This is the starter project from the last video. And this is an iterative implementation. We're not using recursion. There's no method in here that's calling itself. Now, of course, recursion is a method that calls itself. So we're going to want to move some of the code into a method. And essentially, we need to think about what's happening on each iteration of this outer loop. What's happening is on each iteration, we're expanding the sorted partition by 1. Because if you remember in the beginning, we're assuming that the very first element in the array is sorted, and then we pick off the first element in the unsorted partition and we insert it into the sorted partition, and that way we expand the sorted partition by 1, and then we pick off the next element in the unsorted partition, etc., until they're all sorted. It would be nice to have a method that we can call with the number of items that we want to sort, because if we start out with the first 2 items and we sort them, and then we sort the 3 items, and then 4 items, and then 5 items, and then 6 items, and then 7 items, we'll have ended up sorting the entire array. So we're going to move our code into a method that accepts an array and the number of items we want to sort. So we'll say public static void insertion sort, and it's going to receive an int array, the input array, and an int of the number of items we want to sort. And we always assume that we're starting at the front of the array. So in our method, our recursive method, we're going to need a breaking condition. We want to know when to stop the recursion. And the breaking condition we're going to use is if num items is less than 2. And if it is, we're going to return, because when we have 1 item, by definition, that 1 item is sorted. And so when we get down to calling this insertion sort with 1 item, that will break the recursion. And then what do we want to do in here? Well, we want to do an insertion sort with the same input array, but with 1 less items. So when we're called with 2 items or more, which means that we have work to do, before we sort the items we're called with, we're going to sort num items minus 1. So if we're called in the beginning to sort 7 items, we'll say, okay, we'll first sort the first 6 items. And then after we've sorted the first 6 items, we'll sort that final item. And so we'll say essentially what we did up here. And so I'm going to copy this code. We're going to have to change it a bit, and I'm going to paste it down here. Let me change all of the occurrences of int array to input. Input and input, input, and let's put input here. And instead of a first unsorted index, we're going to use num items minus 1. So we'll put num items minus 1 here, and we're going to put num items minus 1 here. And that's it. That's all we have to do. So what's going on here? Well, when we call the method with the entire array, we're going to have 7 items. So we're going to check whether we have more than 1 item, and we do. And so what we're going to say is, well, let's first sort the first 6 items. And so by the time we return from this method, the first 6 items in the array have been sorted, and we want to just sort now the 7th item, the very last item. So we started out with the entire thing. By the time we get here, we've sorted the first 6 elements. So everybody's sorted at this point except minus 22. And what we're going to do is just a regular insertion sort, but instead of a loop, we're just doing 1 iteration. And that'll be for the element that's at num items minus 1. So for the entire array, that would be input 6, which is minus 22. And then we're going to say for I equals 6, I is greater than 0, and input I minus 1 is greater than new element. So we're looking for the insertion point here. I minus minus, as long as the element is greater than new element, we're going to keep looking for the insertion point, because we want to find the first element that's less than or equal to the one we want to insert, because when we find that element, we'll know we found the insertion point. And so as we're looking for this element, of course, we're shifting elements up because we have to make room for the insertion. And when we drop out of this loop, I will be the insertion point of the new element. So instead of using a loop to increase the sorted partition from left to right, we're using recursion to increase the sorted partition from left to right. And I'll show you that in a minute when I add some print line statements so we can see what's going on. So what I'm going to do is I'm going to comment out this sort, obviously, but I'm going to leave it there so you can see it. And let's do the very first call to insertion sort. So that'll be insertion sort, and it'll be our int array. And when we call the method, we want to sort the entire array. And so what's going to happen is we're going to come in here. Num items will be 7 because that's int array.length. This condition will fail, and we're going to say, okay, well then let's call insertion sort to sort the first 6 items in the array. And then that'll come in and it'll say, okay, well let's call insertion sort to sort the first 5 items in the array. And then the first 4 items, 3 items, 2 items, etc. until we come in with just 1 item. And then the recursive stack will start to unravel. The recursive call that called insertion sort with 1 item will be able to continue executing. And it will, as you can see, there's no loop in here. And so each recursive call handles 1 element. And so each recursive call grows the sorted partition by 1. It's exactly what we were doing here in this outer loop. Except we've essentially replaced this for loop with recursion. So let's run just to see if this works. I'm going to rebuild the project. That sometimes happens. So I'm going to say rebuild the project. And now let's try running. And we get minus 22, minus 15, 1, 7, 20, 35, and 55. So our recursive sort is working. Let's add a few print line statements so we can understand better what's going on. I'm going to add some actually to the end here, or after we finished a call to insertion sort. Just before we exit, I'll say system.out.println result of call when num items equals, and we'll print the num items, and then we'll say for I equals 0, I less than int array.length, I plus plus, that should be input actually because we're inside the method, system.out.println input I, let's print everything on one line. And then we'll say system.out.print, and we'll put a comma there. So we'll print the array out on one line. And then I'll just do a system.out.print line so that we get a new line there. And I'm going to also print out a divider so that we can kind of see what's happening on each iteration. Okay, so let's run again. Okay, so let me pull this up a bit so we can see what's going on. So when the number of items is 2, let me scroll up here. So this is our original array, and we start out by saying that 20 is sorted. That's the way that the insertion sort works. So 20 is sorted, and we want to pick off the first element in the unsorted partition and insert it into its proper place in the sorted partition. So when the number of items equals 2, the result of our sort is 20 and 35. It looks like we haven't done anything, but we have. It's just that 35 happens to be greater than 20. When the number of items is 3, you'll notice that we've picked off minus 15, and we've put it into its correct sorted position. And this is exactly what we were doing in the iterative insertion sort, except we were doing this as part of a for loop. But now each of these is a call to the insertion sort method. So we're, as I said before, instead of using a for loop, we're replacing that with recursive calls. When the number of items is 4, we want to add 7 into the sorted partition, and we did. So now 7 is in its correct spot. When the number of items is 5, 55 has been added in. When the number of items is 6, we've added in 1. And then finally, when the number of items is 7, we add in minus 22, and we're finished. And you'll notice that the recursive calls complete in the reverse order that they were called. I'll just pull this down now. because we called insertion sort with 7, but the first call to return is the one with 2 items. We don't see a printout for num items equals 1 because we just return, so we never make it down to the print statements. So when num is 1, we just kick out. And when that happens, we would return to the recursive call with num items equals to 2. And so it would continue executing from here, and when the number of items is 2, it wants to make sure that the first 2 elements in the array are sorted, so it's going to handle 35. And then when the number of items is 3, it wants to make sure that the first 3 items are sorted, and so that's when it handles minus 15. This is what a recursive insertion sort looks like. As I said, instead of using a loop to grow the sorted partition, we're using recursion to grow the sorted partition. In the iterative solution, each iteration of the loop grows the sorted partition by 1, and in the insertion sort, each call to the method grows the sorted partition by 1. So hopefully these print statements have helped you to see what's going on. Remember that we needed a breaking condition, otherwise this recursion would never finish. But otherwise, the code's very, very similar. Apart from making the recursive call, this here was a copy-paste job. We just needed to change it to use the number of items minus 1. And of course, we changed int array to input. But this code here is doing exactly what this code here is doing. And so for the recursion, we just needed to replace the loop. Okay, so that's it for challenge number 2. I'll see you in challenge number 3.